again. So the first question was saying prove that NMLP is a cyclic quadrilateral. Right, before I do the question, I just want to remind you that there are three ways that you can use to prove that a quadrilateral is cyclic. Okay? You use the three cyclic quad theorems. That is the first one. Okay, this year I taught the theorems in a different order. So my theorem 4 was angles in the same segment. Okay, so the converse of the angles in the same segment theorem, you can use that to prove that a quadrilateral is cyclic. Okay, then theorem 5, opposite angles of the cyclic quadrilateral are supplementary. You can use the converse to prove that a quadrilateral is cyclic. If you manage to prove that if you add the opposite angles, okay, if they add up to 180, then you can conclude that it is a what? A cyclic quad. Then theorem 6, which is the exterior angle of a cyclic quad theorem, an exterior angle of a cyclic quad is equal to an opposite interior angle. Okay? And you use the converse of that to prove that a quadrilateral is cyclic. Now, this type of a question is a very common question in examinations. Okay, be ready for it. Okay, in your trial examination and the final examination. Okay, we use the converses of the cyclic quad theorems, and there are 3 cyclic quad theorems. So you don't have to get confused what to do when you see a question like that. Okay, so this is how I'm going to do it. I don't know how you did it, but I'm going to do it this way. My 4 vertices are N. Please, at the moment, it's not a cyclic quad, so I can't say it's a cyclic quad because I have to prove that it is. So NMLP, okay, it has got those 4 vertices. Okay, I'm sure you can see the diagram that we have got a set of lines that are parallel, right? So this angle here, angle K, is equal to X. Okay, and that angle is going to be equal to angle L1. They are corresponding angles. Okay, at the same time, okay, this angle, that is P1, it's equal to angle X because of the tan-cot theorem. Okay, so once I prove that this angle here, that is P1, is equal to L1, then I can say NMLP is a cyclic quadrilateral because of converse angles in the same segment. Okay, so that's how I'm going to do it. Is there anybody else who did it in a different way? Okay, I want you to tell me after I finish. Okay, so first thing I'll say K, angle K is equal to angle L1, and both are equal to X. And the reason, corresponding angles. Remember to state the lines that are parallel. So we have PK. So here we say PK is parallel to NL. Why are you talking? PK is equal, it is parallel to NL. Then I've got P1 being equal to angle K, and both are equal to X, and that's because of the tan-cot theorem. Okay, what this means is I can say therefore angle P1 is equal to angle L1. Therefore, NMLP is a cyclic quad. Okay, my reason will be converse angles in the same segment. And please, This word here is very important. That word converse. Yes.
You can also say line subtends equal angles.
Yes. If you want, you can also say line subtends equal angles. And the line that we'll be talking about is NM, because it's a common chord, or it's a common line which subtends both angles. So if you want, you can say what Mr. Mtem said. You can say line subtends equal angles. Okay, that's another reason. I prefer converse angles in the same segment. Okay. All right. So you need to make sure that you practice how to prove that a quadrilateral is cyclic. Okay, there are three ways. Use the converse of theorem 4, that is the converse of the angles in the same segment theorem. The converse of theorem 5, opposite angles of a cyclic quad are supplemented. The converse of theorem 6, exterior angle of a cyclic quad is equal to an interior opposite angle. No need to become nervous when you see a question like that. Okay, there's no need for you to have a heartbeat which increases when you see that. No. All right. Then the next one, prove that KLP is an isosceles triangle. Right? In most cases, geometry questions, they have a connection in most cases. So if you're asked to prove that in the first part like this, that NMLP is a cyclic quad, it means it is now a cyclic quad because we have proved it. So in 6.2, we now need to carry on to prove that KLP is an isosceles triangle. All right, KLP is this triangle. KLP is that triangle. Okay, so we need to prove that it is an isosceles. Okay, so we already have angle K equals X. Okay, before we carry on, Shweta, can you? Okay, so that's NP and NM. That's NM. Okay, now why am I writing this? It's because for me to say that this angle is equal to X, it is based on those tangents being equal. Okay, so I'll then say, therefore, M1, in fact, let me just write that P1. P1 I've got it before. P1 equal to X because of tan chord theorem. Okay, which means M1 is equal to P1 and both are equal to X because they are angles opposite equal sides. Okay, so what that means is, okay, I've proved that those two are both equal to X. Now, this angle here, this one here, it's going to be equal to X because we proved in the first part of the question that NMLP is a cyclic quad. So I can say M1 is equal to L2 and both are equal to X. This is because of angles in the same segment. Okay? And then the other thing, we know that L1 is equal to X. Okay? Or I can just write it down if I want. So I can say P1 is equal to L1. Both are equal to X, and the reason angles in the same segment, but we proved in the previous question. Okay, so you can write proved in 6.1 if you want. Okay, yeah, because we proved this P1 equal to L1. Right, so this angle here is going to be equal to, so let me identify my triangle. I'll say in triangle KLP, okay, KLP, angle MLP is equal to, okay, I need to get that, so it's equal to P, that's P3, P3 plus X. and this is going to be exterior angle of a triangle. So this one here is 2x. So I can say P3 is equal to 2x minus x, which gives me what? Which gives me x. Right. Furthermore, I'm just going to write this one here separately, and I'll say L3 is equal to 180 degrees minus 2x. That's angles on a straight line. Okay. Then I'll say therefore KLP is isosceles. Okay, it's 6 marks, so I suggest that you provide as much information as possible. Okay. The more information you provide in terms of statements and reasons, you are more likely to get the full 6 marks than providing less information. Okay. So that's how you could do the question. I don't know if there's anybody who are approaching it a different way. Okay, co-interior angle.